Okay, for number 2, it says formic acid ionizes in water to form a formate ion and a hydronium ion. So you have the formula. It ionizes water and creates hydronium and CO2H minus. Okay, so there is the overall reaction formula. A says, what is the acid in the forward reaction? For those of you that stayed on the Zoom, I told you the easiest way to answer this question is to ask yourself, instead, what is the acid? Ask yourself, what is losing a hydrogen or a proton? Because back from number 1, if it is losing a hydrogen, it's going to be an acid. If it's gaining a hydrogen, it's going to be a base. So looking at this, it goes from HCO to H. Over here to this side, it has one less hydrogen. So that means that this guy has lost a hydrogen, thus making it an acid. Okay? Over here, it becomes its base. So those are partners. So that's going to be the conjugate base. And I'll put brackets to show that these two are with one another. And then this one, if this is the acid, that must mean that this one is the base, okay? You can only be one or the other. So obviously this one's the base, and we also know it's a base because it's going from having 2 hydrogens to having 3 hydrogens. And because this one gained a hydrogen, it makes it an acid. And they are partners. So it's called a conjugate pair. So basically, whichever one, they look kind of like one another. There's the only difference is a hydrogen. Those are going to be a conjugate pair. Okay, so for A, what is the acid in the forward reaction? Meaning just as you go across, which one's the acid? That's going to be acid, or excuse me, HCO2H. And then what is the conjugate base? It's going to be his partner, which is CO2H minus. And the name for this, when you lose a hydrogen or you lose a proton, is called deprotonation. For number 3, it's going to be the same concept, except for we have 2 reactions. So A is asking, what is the acid in the forward direction of the first reaction? So we're going to be looking at this equation right here. So basically, again, ask yourself which one's the acid or which one is losing the hydrogen. So you have H2SO4 becoming just HSO4, all right? And H2O becoming H3O, so it's gaining a hydrogen. This one is losing, so that makes the sulfuric acid your acid. And then B asks, what is the conjugate base of this? So H2SO4's partner is HSO4, okay? And then for C, it says, what is the acid in the forward direction of the second reaction? So which one of these is losing a hydrogen? Again, we see HSO4 is losing a hydrogen and becoming SO4 minus 2. Okay? And again, those are going to be partners called a conjugate pair. This is the acid. This is a conjugate base. Acid, conjugate base. And then if it were to ask you, no, it doesn't ask, but it would say base, conjugate acid, base, conjugate acid, because of the hydrogen that is gained. All right, for number 4, you guys can find that in your notes. You can talk about how acids taste sour, reactive with active metals, produce hydrogen gas, can neutralize a base, and there you guys can say bases usually taste bitter, they're slippery, and neutralize acids. So you guys can just pull those kinds of things from your notes. So for number 5, it says a young chemist measures the hydronium ion concentration, hydroxide ion concentration in aqueous solution at 25 degrees Celsius. He reports that the hydronium ion concentration is 1 times 10 to the negative 8, and the hydroxide ion concentration is also 1.0 times 10 to the negative 8. And his lab instructor tells him to go back to the lab and make the measurements again. Why? So obviously, if he's having to do it again, he's wrong. So we want to know why. So if you guys look back, H3O concentration times OH concentration is supposed to equal 1 times 10 to the negative 14. And that's where we get our pH scale, because both of these numbers are supposed to be 1 times 10 to the negative 7 and 1 times 10 to the negative 7, thus giving you 1 times 10 to the negative 14. He did not get that. He got negative 8 and negative 8. So if you multiply these together, you're going to get 1.0 times 10 to the negative 16. That is incorrect. So he was off by one of his exponents. And that is the reasoning behind why we know he is incorrect. Okay, for number 6, it's asking you if HCO3 minus is an acid or base, or both, or neither. It would be both, because it has the ability to release this hydrogen. If it releases that hydrogen, that would give it the characteristic of an acid. Now, it also has the ability to accept a hydrogen. See, because of this negative charge right here, it has the ability to accept one more hydrogen to make it neutral. So then it can become carbonic acid and be neutral. Or it could lose that hydrogen and just become carbonate. Okay? That would be -2. So if it depends on the environment that it's put in. If you put HCO3 with a base, it's going to act as an acid. And if you put it with an acid, it will act as a base, and that will depend on whether it gains or releases a hydrogen ion. For number 7, all Bronsted-Lowry acids accept protons is what the problem says. That is false. It is Bronsted-Lowry bases that accept protons. The acids release or give the protons. Okay? And then it's going to be the bases that accept. All right, and then for number 8, it asks us all Arrhenius base donate protons. That's going to be the exact same thing as the Bronsted-Lowry ones. They have the same characteristic, the same description on whether they give or receive hydrogens. So this one is also going to be false for the exact same reason that the Bronsted-Lowry one was. Okay, for number 9, I didn't realize that A and D were I gave you guys the same exact numbers, so you do not have to do both of those, just do A. These ones are asking you for the hydronium ion concentration and the pH of each solution. So, our equation for pH, you guys remember, is the negative log of your hydronium ion concentration. Now I will tell you all these numbers here are your hydronium ion concentrations. So you guys don't really actually have to do that part. Just use these to plug in to find your pH. So if you do the negative log of 1.0 times 10 to the negative 5, you will get a pH of 5. And then if you wanted to check your work, you could do the equation for the hydronium ion concentration, which is 10 raised to the negative pH, which equals the same thing as 1.0 times 10 to the negative 5. So for number 9, you guys just really need to solve for pH. And then for B, you do the same thing. Negative log okay. And when you do this one, you will get 2.3. Again, if you plug that in, you will get the same number, 5.0 times 10 to the negative 3 for your hydronium ion concentration. And then for C, I'll go ahead and do C, negative log of 1.0 times 10 to the negative 1. Hold on one second, I need my calculator.